Rules of Differentiation, Part 3. Let's start with the review. We'll start with the constant rule. The derivative of a constant is 0. The derivative of x with respect to x is equal to 1. Derivative of x squared with respect to x is equal to 2x. The derivative of x to the 3 with respect to x is 3x squared. And in general, the derivative of x to the n power with respect to x is equal to n times x to the n minus 1 power. The derivative of a constant times a function is equal to the constant times the derivative of the function. The derivative of a sum is the sum of the derivatives. Suppose a stone is dropped from a 784-foot-high building. Its position in feet above the ground is given by d of t, which is equal to negative 16 t squared plus 784, where t is seconds. Find the velocity of the stone when it hits the ground, and be sure to give units. This involves two questions. The first question is, when does the stone hit the ground? And secondly, at that time, what is the velocity of the stone? To find when the stone hits the ground, we take d of t and set it equal to 0. So we need to solve for t when d of t equals 0. And when we do that, we get 7. We also get an answer of negative 7, but we ignore that answer because we're only interested in the time after the stone is dropped. So the stone hits the ground at t equals 7 seconds. At that time, what is the velocity of the stone? Well, let's find the velocity function. That involves finding the derivative of t squared and the derivative of 784. Derivative of t squared is 2t. Derivative of 784 is 0. After you simplify, you get the velocity function is equal to negative 32 times t. At 7 seconds, the velocity is equal to negative 32 times 7, or negative 224 feet per second. So at impact, the velocity is negative 224 feet per second. Before we close on this section, I want to show you a quotient. A quotient just means I've got a function over a function. And we're going to learn in the next section how to handle such a quotient. And we'll use a rule called the quotient rule. The warning I want to give you before you get into that section is that just because a function is presented to you as a quotient, you don't necessarily have to use the quotient rule. So if I don't want to use the quotient rule, and right now I can't because I don't know what the quotient rule is, if I'm not going to use the quotient rule, how would I find the derivative of this function? Well, one thing I could do is I could simplify it first. Take each term in the numerator and divide it by 4x. When I do that, I get a polynomial. Well, I know how to find the derivative of a polynomial. I'm just going to use the rule that the derivative of the sum is the sum of the derivatives, and then also use my constant multiple rule. So y prime is equal to 3 times the derivative of x to the 4 minus 2 times x to the 1 plus the derivative of 3. And by now we're pretty efficient at that. The derivative of x to the 4 is 4x to the 3, the derivative of x is 1, and the derivative of 3 is 0. And so I get an answer of 12x to the third minus 2. And I did that without using the quotient rule. Now, sometimes you have to use the quotient rule, and so in the next section I'll tell you how to use the quotient rule. But if you don't have to use it, please don't, because it'll waste your time, and I'm sure you've got better things to do. Take care and have a great day.